Given y equals f of x equals the cosine of x, quick, graph y equals f at the opposite of x equals the cosine of the opposite of x by hand, two different ways, and then decide if this function is even, odd, or neither. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed. Press pause as needed anytime during this video. The first way is quadrant by quadrant. If x is in quadrant 1, which means x is between 0 and pi over 2, then the opposite of x is going to be in quadrant 4 between 0 and negative pi over 2. But in quadrants 1 and 4, the cosine of x and the cosine of the opposite of x have the same values. So if x is in quadrant 1, the cosine of the opposite x is equal to the cosine of x. A similar result will occur if x is in quadrant 4. Let's investigate. So if x is between 3 pi over 2 and 2 pi, the opposite of x is going to be in quadrant 1 between negative 2 pi and negative 3 pi over 2. But in quadrants 4 and in quadrant 1, cosine of x and the cosine of the opposite of x have the same exact values. So if x is in quadrant 4, the cosine of the opposite of x equals the cosine of x. If x is in quadrant 2, between pi over 2 and pi, then the opposite of x is in quadrant 3, where x is between negative pi and negative pi over 2. In quadrants 2 and 3, the cosine of x and cosine of the opposite of x have the same values. They're both negative in those quadrants. So if x is in quadrant 2, the cosine of the opposite of x equals, you guessed it, the cosine of x. And finally, if x is in quadrant 3, that is between pi and 3 pi over 2, then its opposite will be in quadrant 2 between negative pi and negative 3 pi over 2. And in quadrants 3 and 2, the cosine of x and the cosine of the opposite x have the same values. They're negative in both of those quadrants. So if x is in quadrant 3, the cosine of the opposite of x equals the cosine of x. Therefore, in all four quadrants, cosine of the opposite of x is equal to the cosine of x, which is the definition of an even function. So the cosine is an even function. The graph of parent function y equals cosine of x is identical to the graph of y equals the cosine of the opposite of x. So there's the cosine of the opposite of x, cosine of x, cosine of the opposite of x, cosine of x. Second way, using a table. Pause to complete the table. And those are the values on the axes. We need to create a second table for the cosine of the opposite of x. The values of x will stay the same. What we're going to do is take the opposite of those values, then take the cosine of that value. Pause to complete the table. So the cosine of 0 is cosine opposite of 0, which is 1. So we can plot 0, 1. Take the opposite of pi over 2, would be negative pi over 2. But the cosine of that is also the same as the cosine of 3 pi over 2. Those are 2 pi or a period apart, those arguments. So that's equal to 0. And we'll plot pi over 2, 0. Cosine of the opposite of pi is equal to cosine of pi. Again, the arguments are a period apart, 2 pi. And so that's equal to negative 1. The cosine of negative 3 pi over 2 is exactly the same as the cosine of positive pi over 2, which is equal to 0. So 3 pi over 2 comma 0. And finally, 2 pi, the opposite of that's negative 2 pi, and the cosine of that is the same as the cosine of 0, which is 1. And we'll plot 2 pi comma 1. Connect the points as a cosine curve, concave down, concave up, concave down. We've graphed one period. Let's graph another period to the left by going back a period, 2 pi, from each of the points, especially the points of interest, and connect those as another cosine wave. Comparing that to the cosine function, we can see that those two are identical. We call that an identity, actually. The cosine of the opposite of x is equal to cosine of x. Cosine is an even function.